Hey guys, welcome back to another video. Today we'll be covering another video on the logic series, formal logic specifically. We are covering the categorical syllogism again, but this is part 2. Mainly because I want to add some more stuff that I think would be helpful. So this video kind of contains some preliminaries to the first video and some further advanced stuff, but I will do my best to explain. Now note that I'm starting school in a bit, say like 3 weeks, 2 weeks. So I will probably not be posting regularly like I did in the summer, which bums me out because I really love posting videos. I do a lot of notes on books. Mostly on my free time, I just read and I take notes, listen to music or something. But that's basically how I do my videos. But yeah, let's get started. Um, in the previous video, I really went over the basics of a categorical syllogism, how to construct them, how to criticize them. In my next video, I think I'm going to be covering the species of syllogism. So this includes the anthememe, the epikyrema. The epikyrema is just the proof in the syllogism. The anthememe is a syllogism with a hidden premise. So it has an antecedent and then a consequent. Um, and then a sorieties, which is a long chain of syllogisms. But that'll be my next video. In the previous video, I believe I just went over the basics with what Reverend Charles Coppens gave us, because that's the book I'm using. But in this video, I'm using more resources. So I'm using the Stanford Encyclopedia of Philosophies of Aristotle's Logic. I am using Reverend Charles Coppens' book and an article. I think it's 1,000 words philosophy. It's called Classical Syllogisms. It's really good article. One of the best articles I've read for categorical syllogisms or to understand them. So in this video, I'm going to be giving you a comprehensive overview of what mood is, the mood of propositions and a syllogism, the square of opposition, which you might have heard before, and the relationship of propositions. 3. We are going to learn about the terms in a syllogism. 4. The figures of syllogisms. 5. The distribution of terms, which is just a review when terms are taken in their full extension. And 6. How to interpret Latin mnemonics, and that will be fun. 7. What is the difference between validity and soundness? And 8. How to prove syllogisms using 2 methods. And 9. We'll just learn some basic notation from Stanford's Encyclopedia of Philosophy. Okay, so at least we know now, right, if you've watched the first video or you've had some background knowledge, that a syllogism is a 3-proposition argument. It is 2 premises and a conclusion, 3 unique terms. Both of your premises cannot be negative, and generally syllogisms follows 8 rules, right? So, in a syllogism, the conclusion is contained in the premises, or what results is what is implicitly in the premise. If we were to affirm the premise, we must also grant the conclusion. Now, this might kind of be deceiving, but but specifically we will call this a demonstration, right? Because we could also have an inductive syllogism. But when the conclusion is implicitly contained in the premises, or what results follows necessarily from what is assumed, then we call that a demonstration, right? I think in my last video I went over what a dialectic was, right? As for example, if I say all men are mortal, Socrates is a man, therefore Socrates is mortal. The conclusion that therefore Socrates is mortal, note that therefore is the consequent, while Socrates is mortal is the consequent. And this will be crucial because I think I'll cover soon scholastic disputation, which will be a very fun video in my opinion. But this is very important to know. But notice that the conclusion is implicitly contained in the premise, where the major premise, which is all men are mortal, implies the conclusion, and then premise 2, which is the minor premise, confirms it. So it goes Socrates is a man, and therefore Socrates is mortal. Now, remember, categorical propositions are propositions that absolutely deny or affirm something of a set of subject. Now, categorical propositions have what we call moods, which is their quality plus quantity. So what the heck is a quality of a proposition? So a quality of a proposition in this scenario means that either it's affirmative or it's negative. And the quantity of a proposition is how much does it cover. First, if it's universal or particular. For example, if I say all swans are white, I am affirming something of every swan. So that's a universal affirmative. So we name the mood of a proposition quantity, then quality. So if I said no swans are white, that would be a universal negative. Thus, for example, as I've said, every S is P. This is a universal affirmative. But if we say no S is P, obviously that's universal negative, right? Because we name quantity then quality. Without further ado, we must note that there is 4 moods, 4 categorical propositions or sentences, and they take the form of subject plus predicate, as I've already noted. The 4 moods have 4 corresponding letters, and this is how they are. A, E, I, O, and this is how I just remember. A, E, I, O. I repeat that in my head 1,000 times. A, universal affirmative. E, universal negative. I, particular affirmative. That is some S is P. Some indicates particular. O, particular negative. That is some S is not P. And note that, in the mood of a proposition is quantity, then quality. And Aristotle argues that there is 3 sound conversions for the mood of propositions. So the mood A, or the universal affirmative, converts to the particular affirmative. That is, if I say every S is P, I can logically convert that to some P is S. Why? Because I cannot go from every S is P to every P is S. If I say every dog is an animal, I cannot say that every animal is a dog, right? And so I can only say that if every dog is an animal, I can say therefore some animals are dogs. So that is why A converts to I, that is the universal converts to the particular. The no S is P is different on the other hand. The universal negative converts back to the universal negative. That is, if I say no S is P, then no P is S, right? If no man is, let's think of if no man is a dog, then no dog is a man, right? So that's logically follows, so E to E. And then the particular affirmative, some S is P, logically converts to some P is S. That is I to I, so particular to particular. So if I say some, some men are handsome. Therefore, some handsome men are. Some men are handsome people. Therefore, some handsome people are men. That logically follows. But for the particular negative, that is, some S is not P, there is no conversion for that, unfortunately. So the only moods that are going to be logically or soundly converted is going to be AEI. That is universal affirmative, universal negative, and particular affirmative. We exclude O. But the rule for converting is simply just you switch the subject and the predicate. Okay, so this is the square of opposition, a logic tool used to evaluate claims, propositions, arguments. This is a very crucial tool. Alright, now obviously on the screen you see A, E, I, O, and you see, oh, those are the moods of the propositions, right? Mood of the categorical sentences. Oh, excuse me. Now they have relationships to them, right? So A and E are related as contraries, meaning that they cannot both be true, but can both be false. And that's where I'm going to get on to the next slide. So each mood right here has a relationship with each other. And you're going to see why this is so crucial right now. So what is the relationship between all the moods? So first, the relationship between the universal affirmative and the universal negative, that is, if I say every S is P and no S is P, they are contraries, meaning both cannot be true at the same time, but can be both false at the same time. And the relationship between the universal affirmative to the particular affirmative, or the universal negative to the particular negative, which is A to I, E to O, they are called subalterns, a relationship between two categorical propositions where one is implied by the other but not vice versa. So for example, if I say every dog is an animal, it logically follows, I can logically say that, therefore some dogs are animals, right? Even though all dogs are animals, so all dogs are animals already implicitly contains that some dogs are animals, But if I only solely go from some dogs are animals, I cannot say therefore all dogs are animals, even though that's true. So that's just what it means. So A implies I, but I doesn't imply A back. E implies O, but O doesn't imply E back, right? And by the letters I'm mentioning, those are the moods of the categorical propositions. Now, the relationship between the particulars, that is that some S is not P and some S is P, that is I and O, they are called subcontraries, meaning they can be both true at the same time, but cannot both be false at the same time. Now, contradictories. This is where we need to make a crucial point or distinction. A and E, that is no S is P and every S is P, are not contradictions. Why? Because they agree in quantity but not in quality. So contradictories are two propositions where one is the direct negation of the other. If one is true, the other is false, and vice versa. They cannot both be true or both be false at the same time. That is to say that necessarily one is true, the other is false. That is also to say that two propositions are both opposed in quantity and quality. So the only contradictories, if we go back here to the square, is A and O and E to I. So A contradicts O contradicts A, E contradicts I contradicts E. A and E do not contradict each other in the sense of them being contradictories. Rather, they are contraries, meaning they are both true. I mean, they cannot both be true at the same time, but they can be both false. But that's the problem, because contradictories cannot be both true nor both false. One has to be true. Therefore, A and E are not contradictories. Only A and O and E and I. Okay, so hopefully that made sense. But contradictories include every S is P and some S is not P, as I've said, or no S is P and some S is P, which disagree both in quantity and quality. So, for example, if you go back, every S is P and some S is not P, they disagree in quantity. Some versus every, and not versus is, right? And that's why they're contradictions. Okay, thus, after we figure out the moods of categorical propositions, only then are we able to figure out the mood of a syllogism. So simply, the mood of a syllogism is really definitionally just the order of the moods of its propositions. For example, A, which indicates three universal propositions, or E, that is a universal negative, then a universal affirmative, then a universal negative, etc. Thus, for example, if I say all men are mortal, Socrates is a man, therefore Socrates is mortal. This is a syllogism, which is in its most perfect form, and we're going to get into perfect form or figures. Now you might question, why premise 2 and the conclusion are universal affirmatives? It seems the claim that Socrates is a man is a particular affirmative, but it's actually not. This is because universal affirmatives can also express singular statements, which are categorical statements about a single thing. So Socrates is a man is just all persons identical with Socrates are men. Or you also have to note that in the last video I mentioned that singular terms are taken in their full extension. That is, if I say Luther is a monk, Luther is taken in its full extension. That is saying all that Luther is a monk, but monk is not taken in its full extension. That is, if I say Luther is a monk, I cannot say therefore every monk is Luther. So that's why Luther is a monk is the same as all C is A. Because in all C is A, only C is distributed, but not A. Just note that in every affirmative proposition, the predicate will never be distributed. And in every negative, what's it called? Sorry. Actually, no, never mind. We'll get into the distribution of terms in a bit, but that will be in the later slide. I don't want to spoil it for you right now because there is the universal negative, which has both of the terms distributed, and then the particular negative, which only has the predicate distributed. So, moving on, the proposition, as I've said, Socrates is a man, just is the same as all A is B, because Socrates is taken in its full extension. Okay. Now, in a syllogism, I have noted that one of the rules is that we can only have 3 unique terms and no more than 3, because it is necessary that there be a term that connects the other terms for there to even be a connection in the syllogism, right? Thus, we have The three terms in a syllogism are: 1, a major term; 2nd, a middle term; and thirdly, a minor term. The major term is the predicate of the conclusion. That is, if I say, therefore Socrates is a man, man is the major term. The middle term is the term that appears in both the major and minor premise and is also called the connection of the syllogism. The minor term is the subject of the conclusion. That is, if I say, therefore Socrates is man, Socrates is the minor term. Now, both the major and the minor terms are usually referred to as extremes. You might have heard this before, but that is what they are called usually. Thus, in the syllogism, if I say all philosophers are handsome, then I say I am a philosopher, therefore I am handsome. Philosopher is the middle term since it appears in premise 1 and premise 2. Handsome is the major term, and therefore I can say that the major premise is premise 1, that is all philosophers are handsome. And I am a philosopher, which is true, therefore I am handsome. This is infallibly true. So this is self-evident. Just kidding, right? Obviously it's not self-evident because how do you know I'm not a monster, right? Just kidding. And I or me, which is the minor term, which is me right here. Now we also have a major premise, that is a premise containing the major term, and a minor premise, that is the premise containing the minor term. That is why in premise 1, all philosophers are handsome, is the major premise. The minor premise is premise 2 because it contains the subject, and premise 1 contains the predicate of the conclusion. Thus, in a syllogism, we usually structure it like this for arguments. So when you ever debate someone, also when you debate someone, please debate, how do I say it? Debate modestly, right? I've seen a lot of aristical styles of arguments that are more rhetoric than really just like arguments employed. But I think it'd be best if you do it like this. Why? Because if you structure a syllogism like this, if you structure your opponent's syllogism like this, like when you're ever discussing with someone, you want to put their argument in a syllogism, whether it be an enthymeme, epicharema, or Sorites, or just regular categorical syllogism in its most basic form. You structure it like this. That is, major premise, all men are mortal; minor premise, Socrates is a man; consequence, therefore, consequent is Socrates is mortal. And really, if like you want to critique, like let's say, just for example, this is not a real critique in my opinion. If I say, so notice major premise and minor premise. Notice that the middle term is man, right? And if I want to criticize, I could say, well, I could say that it's equivocating on man, but I can also say I distinguish the middle term, that is man, and therefore I have to distinguish the minor premise and the major premise. But that is also called contradistinguishing, because I'm showing how those two senses of man are opposed to each other. So that's basically how you do that. But basically, when you talk or you discuss with someone, make sure you use a syllogism. It's really helpful to use it to critique. But also debate modestly. That is, debate virtuously. Do not, how do I say it? Do not be disrespectful. Be intellectually honest, right? Note that debate is not to win and, have some pride over winning over somebody, because I don't really think that matters at all. Just aim for truth, right? That's the whole point of demonstration. Aristotle says demonstration produces knowledge, right? So that's my advice to you when you're doing this. Alright, moving on from that yap. There are what we call the figures of a syllogism, and these figures are categorized based on the placement of the middle term. So the middle term is the term that appears in both premises, right? So we have 4 figures or 3 figures, but the 4th figure is sometimes noted as the indirect first figure. So in the first figure, the middle term is subject then predicate. Indirect first figure or 4th figure is predicate then subject, and then second figure is both predicate, and then third figure is both subject. How I would memorize this is I would look at it like a W. So it goes like a W, so subject, then predicate, and then second figure, both predicate, and then third figure, both subject, and then indirect, predicate, then subject, which forms like a W, right? Like you go slanted down, and you go 2 straight, and then you go 1 slanted the other way. So that's how I would memorize it. If you can see my mouse, it goes like this. Doop, 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 like that. So that's what I mean by how you can memorize this, because I know like, you're not gonna memorize all the figures in like a day, right? So this would be a good way to memorize. Okay, so we need to note that the first figure is considered the most perfect, and it's actually indemonstrable, even though I think Aristotle reduces one of the two deductions in the first figure to the second figure. So before we get into the table of deductions and how to prove syllogisms, we have to understand the distribution of terms and why it's actually important. Now, a term is said to be distributed when it is taken in its full extension, meaning the idea signifies every one of the objects to which it can apply. That is, for example, if I say every S is P, only the subject S is distributed, but not the predicate P, since P belongs to every S. And a term is distributed when the proposition refers to all members of the class it names. Now look at the statement some S is not P. In this proposition, only the predicate is distributed. A negative proposition distributes its predicate because it excludes all of it from the subject. So just note that in affirmative propositions, the predicate is never going to be distributed, but in a negative proposition, the predicate will always be distributed, since you only really have the universal affirmative and the negative particular. I mean, the universal negative, my bad, not affirmative. Universal negative and particular negative. Now, an affirmative proposition has its predicate undistributed because the predicate is usually wider in extension than the subject. Oops, I think I skipped a slide. Okay, so this is a chart or a table you might have seen from my last video on the distribution of terms. This is really useful, but yeah, this is basically it. So if you want to take a picture, 5, 4, 3, 2, 1, done. Okay, yeah, so I said make sure you watch the previous videos and remember the 8 rules for syllogisms, because that will be so important in critiquing them. Now, we need to get into a little bit more info on Aristotle's logic. Now, Aristotle's logic is different from modern logic in the sense that Aristotle's logic, like in contrast to, let's say, Boolean logic, assumes the existence of the terms in the proposition. So in Aristotle's logic, we say Aristotle's logic has existential import, or assumptions of existence. So according to Aristotle, if I say every S is P, that implies S exists. So if S is empty, meaning that there is no S really in reality, then every S is P is false. So if I say every unicorn has a horn, that statement, according to Aristotle, is false, even though horns is contained in the concept of unicorn. Although we need to distinguish that Aristotle is saying that if unicorns do not exist in reality, then that statement is nonsensical. It's false. So a proposition has existential import if it implies that its subject refers to at least one real thing, or in other words, that the subject class is not empty, or that it exists. Now, it is important to distinguish between the terms of a term, the intentions of a term, between the first and second intentions. So a term can be used in the first intention when a term is used to refer to reality. And 2, a term is used in the second intention, and it is a term used to refer to itself reflexively, referring to itself as a concept or term. So, let's say every unicorn has a horn. This is false in the first intention when we're referring to something in reality. But it's true in the second intention because it's referring reflexively about unicorns, right? So thus it seems that Aristotle's logic takes all terms only in the first intention. Because remember, when Aristotle, or at least the Organon, when they compiled it, because I'm pretty sure there's a whole debate whether Aristotle actually wrote many of his works, but let's just assume that Aristotle wrote. So, when Aristotle was composing the Organon, or he actually didn't compose it, but he just wrote all the logical works in it, and I guess it got composed later. But in the Organon, remember, the whole point of Aristotle's logic is to produce knowledge and demonstration. So Aristotle's method is scientific. It wants to produce new knowledge, produce knowledge of causes, right? Now, we say that every valid... we have to distinguish validity and soundness. Now, we say that every valid argument has their conclusion implicitly contained in their premises. Thus, validity is that if the premises are assumed to be true for the sake of the argument, then the conclusion must also necessarily be true. That is to say, it is not possible for all of its premises to be true and its conclusion false. So, validity is not about the truth or falsity of the premises. But this is different from soundness because soundness requires validity and the truth of the premises. So if, let's say, the argument is invalid but the premises are true, it's not sound. So soundness requires validity plus truth. So we call an argument sound if all of its premises are true and the argument is valid itself. Now for Aristotle, there are 4 kinds of terms Aristotle specified. That is general terms, singular terms, indefinite terms, and empty terms, which we have already discussed. Empty terms are like chimeras, unicorns, round squares, the present king of France. That is funny. Hey, have you ever asked your friend, who is the present king of France? That would be a funny question. Because it doesn't exist, dude. Right? General terms, right, refer to the categories or classes. That is, for example, philosophers, houses, galaxies, let's see what else, gamers, right? And singular terms are just specific names for individuals. So that would be Socrates, Plato, California, anything specific about individuals, right? And indefinite terms are just unclear about being general or singular, right? They're just neither that. So, for example, pleasure, water, time, right? But that's basically it for the terms. But traditionally, the classic approach is general terms. So we only use general terms for classical syllogisms, basically. Okay, before we get into the proof of syllogisms and Latin mnemonic, we must look at some notation. So, in the Stanford notation, it goes like this, AAB. So that just, we need to read first predicate, then subject. So if AAB, then that means every B is A. That is, A belongs to every B. EAB is that no B is A, or that A belongs to no B. IAB is that A belongs to some B, that is, some B is A. And some B is not A translates to A does not belong to all B. Thus, it is read predicate first, then subject. Thus, we can express syllogisms in short like this. That is, AAB, ABC, therefore AAC, which is just read as every B is A, every C is B, therefore every C is A. And as I've said, I've wrote it out for you, and note that the rotated T just means therefore. Oh shoot, skipped a slide. Forgive me. Okay, let's look at the table of deductions. Now, please do not get overwhelmed because this is actually pretty simple, not too hard when you learn it. It takes some time to practice. Okay, so look at the form. Now, notice that the Stanford table of deductions writes the forms of syllogisms in notation. So remember, as I've said, you read the predicate first and then the subject. So if I have AAB, that means A belongs to every B. But it's also just that all B is A. So thus, in the form, if you want to read Barbara, right, look at Barbara, the form of Barbara. Every B is A, every C is B, and therefore every C is A. How do you know that it's every B is A? Because look at the first letter, A. Look, the first letter of the forms for which they simplified the proposition of the syllogisms, it will tell you the mood of that proposition. So if I have IAC, then I can say that some C is A, right? And then remember, the rotated T just means therefore. So do not get confused about that. The mnemonic, right? You might wonder, what the heck is this mnemonic even for? The mnemonics are used to memorize the proofs of a syllogism, the moods of a syllogism, how to prove them, right? And usually what figure they are. So, for example, if you look at Césaire, the first letter C indicates that it's going to be reduced to celerant. And second of all, look at the letters. Now remember, you have to remember the moods of propositions. A, E, I, O. Those are the only 4 moods of propositions. A, E, I, O. The universal affirmative or negative, the particular affirmative or negative, right? Thus, if we look at Barbara, we know that it's an AAA syllogism because look, there's 3 A's in Barbara. but the other letters are kind of just there for pronunciation, except the first letter, because it's sometimes useful in the case of proving, even though we don't have to prove Barbara, as indicates that it's perfect, it's self-evident, it's indemonstrable, it's what every other syllogism is going to be reduced to. And if you look at celerant, celerant, the vowels indicate the mood. Celerant, E-A-E. Dari, A-I-I. Ferio, that is E-I-O. Césaire, so E-A-E. So that is the table of deductions. Now, on the other hand, if we go to proofs, you can see that in the first figure, all of them are perfect, but only two can be like reduced by impossibility if you want. That is Dari and Ferio to Comestries or Césaire, which I'm going to show you how to do in a minute. But notice that Barbara and Celerant are the most perfect syllogisms. They do not need proof. They are the syllogisms that are going to be used to prove every other syllogism. So first figure, most valid, or I guess you could say most perfect. And then the other syllogisms, as you can see, they're written in notation proof. For example, Barocco is going to be reduced via reductio ad absurdum. How do you know? Look at that plus. So it goes, every B is A, some C is not A, assume that every C is B, therefore, Barbara, every C is A, but it was assumed that some C is not A, which contradicts A, because notice how A contradicts O, therefore implying the original conclusion by contradiction, therefore that some C is not B. And that's how you quickly read it. Okay, so the rules for the Latin mnemonics is this. And as I've said, the Latin mnemonics were used by the Latin logicians or philosophers to memorize the moods of syllogisms, the forms of syllogisms, their figure, mood, whatever, and their proof. And this is how to interpret them. First, the vowels, as I've said, indicate the mood of the syllogism. For example, bar, b, r, a, that is all universal affirmatives. The first letters B, C, D, F in imperfect syllogisms show which perfect syllogism is used in the proof. So as for example, Comestries refers to celerant because of the capital letter C or the first letter. C indicates that it's going to be proved via celerant. M means swapping of the order of the premises. For example, desamis. And C, after a vowel, means use a reductio per impossible, that is reductio ad absurdum argument on that premise, only in Barocco and Boccardo, meaning that the only two imperfect syllogisms you ever actually have to reduce to prove it is Barocco and Boccardo. And P, after an A, means that you use an A conversion or a particular conversion on that universal affirmative premise, as for example, darabdi at the end, and it means a conversion of the conclusion, as for example, bomalib, right? Okay. And S after an E or I means use E or I conversion on the premise, as for example, festino at the end. It means conversion of the conclusion, as for example, caminis. I'm pretty sure that's a fourth figure, but it's not shown in the table of deductions. Note that the table of deductions I'm using is only showing the first, second, and third figure. And then the other letters, as I've said, are only for pronunciation, and they really don't carry anything here, and they're trivial. Okay, note that every deduction, every other figure syllogism can be reduced to the first figure. And Aristotle calls a perfect deduction that which needs no other thing, other than the things already stated, for a conclusion or consequence to necessarily follow. An imperfect deduction requires extra, unstated but necessary propositions. So for Aristotle, he regards the perfect deductions as not in need of proof, so that would be like Barbara, celerant, anything in the first figure, kind of like self-evident. On the other hand, Aristotle proves imperfect deductions since they do depend on perfect deductions. For examples of the perfect deductions, as I've said, would be the first figures. Now, in proving imperfect deductions, Aristotle reduces each to a perfect form, therefore completing it. This is done either by a direct proof or by a reductio ad absurdum, showing that denial leads to impossibility. And a direct deduction is a step-by-step argument where each step either follows logically from earlier ones using a basic valid pattern called a first figure deduction, or involves a conversion of one of the earlier premise, or swapping the swapping the order of the premises. And conversion is just simply switching the subject and predicate of a statement to form a new valid one. So here there is a twofold division of proof. Now in the prior analytics, I'm pretty sure Aristotle mentions another called ekithesis, but we are not going to cover that in this video. Now let's take a look at an example of a proof using the Latin mnemonics rules for interpretation. So let's prove disomis. If you go back to the table of deductions, disomis is a third figure syllogism. And if we want to prove disomis, we need to step back and look at first what is the first letter of disomis. The first letter of disomis is D, indicating that it's going to be completed or reduced by dari. So, and then the S after the first letter I, right? Remember, de sa mis. That indicates that it's an IAI syllogism, so the mood is IAI. Notice that the S after the first premise, or the I, indicates a particular conversion, while M indicates the swapping of the order of premises. D indicates that, obviously it's going to be completed by dari, and then the S after the last I in the end indicates a conversion of the conclusion. So it goes like this. Some C is A, to every C is B. If I want to prove the conclusion, therefore some B is A, I have to repeat every C is B, because remember, if I did not have that M, I would repeat some A is C first. But no, I repeat in my third premise or third assumption that every C is B, repetition of premise 2, and 4, swap the order of the premise, so some A is C. But notice that I had to convert premise 1, so some C is A logically converts to some A is C. Remember, for the logical sound conversion rules, some A is C, therefore some A is B, 3 for dari. Now, why do I have to swap the order of the premises? Because if I were to only go from, let's say, some A is C, then every C is B, then that's not valid. Because notice how that's an indirect first figure. Now, note that some A is C, every C is B, is different from every C is B and some A is C. Why? Because remember, the figure of a syllogism is dependent on the placement of its middle term. If the placement of the middle term is not subject then predicate, then it's not going to be a first figure, even if it's almost exactly the same, proposition. So if I go from some A is C and every C is B, that is not first figure. We have to be careful when we are writing proofs for syllogism. When we write proofs for syllogisms and what they're going to be completed to, we have to know the figure of their first figure syllogism. That is why dari here is every C is B, some A is C, therefore some A is B, which is AII syllogism. But notice that it is actually dari. Why? Because notice the placement of the middle term, which is C. It's in every C is B and some A is C. And therefore I conclude some A is B. But notice that because there was an S after the last I of disomis, that indicates that I have to convert the conclusion. Therefore I can convert it to some B is A, thus proving the original conclusion. Sorry if that was a little bit complicated, but if you have any questions, please ask me. But you can also write it like this in notation, as I've said, as the Stanford does. So you can go some C is A, some C is B, that is ABC, all C is B, sorry. ABC is all C is B, and we want to prove that IAB, that is some B is A, and then, we go on and on, just read it out like that. Or you can also write it like how they do it on the table of deductions from Stanford. So it goes like this: some C is A, all C is B, logically convert premise 1, that is, if some C is A, then some A is C, restate premise 2, but then the M indicates the swapping of the order of premises, so you swap it and it becomes all C is B, then some A is C, and therefore we conclude that therefore some A is B. This is dari, perfectly valid. Or it can be written in another notation, which I've seen. It's kind of weird, but it goes like this: AIC, BAC, that is some C is A. Obviously, it's red predicate, then subject, as I've mentioned before. Alright, now let's look at example of an reductio or indirect proof, or proof per impossible. So let's do the two examples, Barocco and Boccardo, since C indicates a indirect proof or reductio. If you have watched my previous video on how to interpret Latin mnemonics, which I made another video on, and I actually did proofs one by one on video and showed you guys how to do it. But make sure you watch that. That's also a helpful video. Alright, let's prove Barocco. Alright, so Barocco goes like this. All B is A, some C is not A. So that's how you know it's a third figure, not third figure, second figure syllogism, because the middle term is both predicate. And then we want to prove the conclusion, therefore some C is not B. Now, in order for you to prove a syllogism via reductio or indirect proof, you have to assume the direct negation of the conclusion, or negation of the conclusion. That is, all C is B. Because why? Because notice that all C is B is a logical contradiction of some C is not B. Both cannot be both true, and both cannot be both false. One is necessarily false, and one is necessarily true. So thus, repetition, all B is A, all C is B, therefore all C is A. 3 for Barbara, right? Because that letter B from Barocco indicates that it's going to be reduced via Barbara. And because we have to, the reason why I repeated premise 1 is I had to make it perfect first figure. So look, all B is A and all C is B. Notice that the middle term is subject and predicate. Perfect. Now I can conclude therefore all C is A. But it was assumed that some C is not A. Thus by contradiction some C is not B. So here we proved our desired conclusion by assuming its direct negation or contradictory, since E contradicts I and A contradicts O, and that is the mood of propositions. And after we show that our conclusion, our newly found conclusion, contradicts one of our earlier premises, we can thus reason by contradiction that the negation of our desired conclusion is necessarily false, or that our conclusion has to be necessarily true. Notice that the now in notation you can write it out like this, even though you don't have to, but if you want to get fancy smanchy whatever, you can write it like all B is A, that is some C is not A, and we assume the contradictory, that is the plus means assume the contradictory of the conclusion, that is every C is B, and then we can conclude via Barbara from AAB and ABC, that's AAC, that is if I conclude from all B is A and all C is B, I can conclude therefore that all C is A. But it was assumed that some C is not A, which contradicts one of our earlier premises, so the new conclusion contradicts the earlier premise. Therefore, by contradiction, we prove the original conclusion that we wanted, that is some C is not B. And that is how it's like that. You can also shorten the proof by not repeating the premise. So if I go like this, thus all B is A, some C is not A, and we want to prove some C is not B, I can just assume all C is B, that is the contradiction of the desired conclusion, and therefore I can reason that all C is A, but then I would just have to mention where I'm getting my premises from, which is from premise 1 and then 3. So 1, 3, Barbara. But it was assumed that some C is not A, thus by contradiction some C is not B. And thus in an indirect proof you want to do this. First, state the desired conclusion you want to prove, or the thesis. For example, to prove all A is B. 2, then state the assumption of the direct negation or contradiction of it. That is, assume some A is not B, right? Because remember, the universal affirmative contradicts the particular negative, while the particular affirmative contradicts the universal negative. Thus, assume some A is not B. Then make sure you also use the square of opposition to verify or help you. 3, use one of the earlier premises. You can repeat them if you want. Just make sure the figure is valid when you're reducing a syllogism to whatever first figure or whatever syllogism you want to. Make sure the figure matches that syllogism. And to derive a conclusion that contradicts one of the earlier assumptions or premises. 4, thus you would have proved your conclusion, since any pair of contradictory propositions, one must necessarily be true and the other false. So if I show that, for example, in a pair of contradictions, that one is false, then the other one necessarily has to be true. Alright, one last reductio, and one last deduction. And I'm going to try to make it short. So let's prove chemistries, step by step. So for example, in chemistries, we know that the letter C at the start indicates it being reduced to celerant. M indicates that we're swapping the order of the premises. The S after the first E, that is after the second premise, indicates the conversion, and S after the conclusion, or the last E, indicates another conversion, but we are converting the conclusion. Thus our proof starts, all A is B, no C is B. To prove that no C is A, and remember we have to convert, therefore we go no B is C. And the reason why we repeat premise 2 into 3 is because we have to swap the order. So no B is C, for all A is B, therefore no A is C. Notice how it's celerant because the middle term B here is in no B is C and all A is B, both first subject then predicate. And thus we can validly conclude, therefore no A is C. But remember, we have to convert the conclusion again because of the S, therefore no C is A. And that's how we prove the original conclusion. And then I can express it like this if you want. As I said, that equal sign right here in the notation just means that they're swapping it. So if I go from every A is B and no B is C, then that's really just the same as saying no B is C and then every A is B. And then I can conclude via celerant. Alright, last proof. We can actually prove dare, which is one of the first figure perfect syllogisms, by reductio from chemistries. Look here. So it goes like this. All B is A, some C is B, and we want to prove the conclusion that some C is A. We assume the contradiction, that is no C is A, and therefore no C is B, and I just can use one of the earlier premises, as I've said, from premise 1, and then I can use the assumption 3 to conclude that no C is B. But then the problem is no C is B contradicts premise 2, that some C is B. Thus by contradiction, some C is A. So we really just proved the conclusion again just by contradiction, showing that the opposite leads to impossibility. Thus, it can also be written like this in notation, and I'm not going to explain it again since my voice is tired. Thanks for watching. My sources are, as I've said, Stanford's Encyclopedia of Philosophy, Reverend Charles Coppens' brief textbook on mental philosophy and logic, an article, and then I used another doc called Formal Logic, or Brief Introduction to Formal Logic by Guilherme Paini. And yeah, that's basically it. Thanks for watching.